Okay, next up is trig substitution. So I think probably one of the hardest parts about trig substitution is when you get to a point where you have 10 integrals on a page and you have to figure out what's happening. So as soon as I see something underneath a radical, I'm going to check to see if it's a substitution question. And in order for it to be a substitution question, the derivative of underneath here needs to be hanging around. So I need a 2x somewhere, or at least an x. And I don't, I have an x squared. So this isn't really working for me. So I'm going to think of a way that I can kind of get rid of that radical. Well, if I had one squared term underneath here, I could get rid of the radical because one squared term underneath the radical, they cancel, the square and square cancel. So what I'm actually going to do is use trig identities. So what I want to do is make this 1 minus sine or cos or something so that this can be changed to an identity. So I'm going to do a let statement. So I'm going to let x equals sine theta. You could also use x equals cos theta in this situation as well, and it would work, okay? So we're going to let x equal sine theta. So dx d theta is cos theta. So dx is cos theta d theta, okay? So I do let x equal sine. Now, hopefully it will seem obvious to you why I picked that. Let's just look at what's happening underneath this radical sign. If I let x equal sine, I end up with 1 minus sine squared, which is cos squared, and the squared square rooted go away, and I end up with cos theta, okay? So that's the reasoning behind picking this, is kind of to get rid of the radical sign. So you have to pick an x so that whatever is underneath there is a Pythagorean identity, okay? So now let's go back and plug everything back in that we know, okay? So dx is now cos theta d theta, so we're just going to write that. So cos theta d theta. X squared, well, if x is sine x squared is sine squared theta. And this whole piece, we just fixed it over here, is cos theta. Okay, now I'm going to do some simplifying, so that goes away. And I end up with 1 over sine squared theta d theta. So now I need to figure out what is the derivative of 1 over sine squared theta, or sorry, integral. So it's not just like a straight up integral. So I need to think about maybe an identity or something like that. So, and this is going to be different every single time, what you do at this next step. There's no like, oh, when this, you always do this. You're going to have to think every single time. So 1 over sine squared is the same thing as cosecant squared theta d theta, which is a straight up integral, okay? So that's minus cotan theta plus c. So now we've integrated, but my question is in x's. I'm not going to leave my answers in thetas. So what I'm going to do is I'm going to go right back to my original let statement, and I'm going to make a triangle to describe it, okay? So if here's my triangle, okay, here's my theta. I let x equal sine theta. So let's say x over 1. Sine is let's go opposite, let's go SOHCAHTOA. So opposite over hypotenuse. So here's this, so opposite over hypotenuse. So this squared minus this squared square rooted goes here, okay? So I just made my triangle. So how I made my triangle is I went back to my let statement, okay? And I formulated, I used this expression that I had used to make a triangle. So if my answer is minus cotan theta plus c, and this is my triangle for theta, then I just use this triangle. So cotan is the opposite of tan, okay? Oh my God. So tan is opposite over adjacent, so cotan is adjacent over opposite. Okay, so we're going to do adjacent over opposite plus c. Ta-da! Is that the most beautiful thing you've ever seen? I'm going to do another example on trig substitution.